In this video, we're going to be solving systems of linear equations using a method called graphing. Linear equations means that all of these are going to be lines. And when we have a system of lines, it means we have more than one line on a graph. In our case, for this video, we're going to be looking at systems that have two lines on a graph. Our job is to find where those two lines intersect, which values of x and y work for both lines. When we look at our problems, we're going to have three different types of answers that might happen. In this first case over here, the two lines that we have on our picture are parallel, meaning they never intersect. If they never intersect, then there is no point that works in both lines, so that would be no solution. In the second picture here, you can see we have two lines that intersect in one spot. This spot of intersection is the one solution that works in both lines. This third case can also happen. When you graph them, you might see that they graph on top of each other, meaning they're actually the same line. If that's true, your answer is going to be that there are infinite number of solutions. That's a little different than all real numbers. All real numbers means everything would work. In this case, we're not saying everything, but we're saying everything on this line, which is an infinite number of answers. Everything on that line would be something that works in both equations. Let's take a look at example 1. We have this equation, y equals 4/3 x minus 3. And from there, we know that the slope of that line is 4/3, and that the y-intercept is -3. We can use that information to graph the line on the graph. So I'm starting at -3, that's my y-intercept, and I'm going to use my slope of positive 4/3. That means we're going up 4 and over 3. And we can continue that, going up 4 and over 3. Remember, a positive slope could be negative over negative. That would be positive. So we could go down 4 over 3. All of these points along this line are things that work in that first linear equation. Next, we need to look at the next equation. The next equation is y equals 1. This is either going to be a horizontal or vertical line. Remember, if you're missing a letter, that means we're horizontal or vertical. Well, where does y equal 1? Y equals 1 here, but also all along here, y is going to be 1. So that means we have a horizontal line at y equal 1. The solution for this systems of equations is where they intersect. So for this one, they're intersecting right here at this point. So what is the coordinates for that point? Well, that point is at 3, 1. So 3, 1 is where those two lines intersect. That is the solution for that systems of equations. And when we say that, what we mean, remember this is x comma y, we mean that x equals 3 and y equals 1 will work if you plug them back into here and if you plug them back into here. Obviously, if we put 1 in for y, 1 is 1. If you put 3 in here for x and 1 in here for y and simplify this, you'll get a true statement as well. Those are the only things that you can plug in here and also here that would work. Let's look at example 2. We're going to take this first equation and try and graph it. Now, unfortunately, it's not really set up in y equal mx plus b or slope-intercept form, so we need to do some moving around. Remember, we want to get y by itself, so I'm going to minus the 2x over to the other side and get y equals -2x minus 4. So that's the first line that we're going to graph. It has a y-intercept of -4, so that's where I'm going to start. and it has a slope of -2. So we're going down 2 and over 1, downright negative, or we could go up 2 and then over -1. It's going to look like that. Everything along that line, everything along that line will work for that first equation. Let's do the next one. This guy right here. Again, we need to do some moving around. We need to get y by itself, so I need to divide by 2. Remember, when you do that, you have to divide everybody by 2. And so here is that equation rearranged. Now let's go graph it. I'm starting at +2, and I have a slope of 4. So from that spot, we are going to go up 4 and over a +1. Or we could go -4, -1. Everything along that blue line will work in the second equation. We want to know which point works in both equations. That is this intersection right here. And the coordinates for that intersection are -1, -2. So if you put x of -1 and y of -2 in here, this would work. It would also work in here, and that's the only spot that would work for both equations. There's lots of things that work on this red line. All these spots work. And there's lots of things that would work on this blue line. But this right here, that's the only one that works in both. Let's try one more. Again, this guy's not set up very nicely for us, so let's move some things around. We want to have y by itself so that we can graph this in y = mx plus b form. So I'm going to minus the 6x over. And we're going to be left with 2y. Now on the other side, those are not like terms, so we can't put them together. I am going to have to divide everybody by 2. I'm going to get -3x plus 1 for that one. So we're going to come over here and start at +1. It has a slope of -3, so we're going down 3 over 1, downright negative. Or we could go up 3 over -1, because that would also be negative. And then we're going to connect our dots to make our line. So all those spots will work for that equation. Let's do the next one. We're going to rewrite this equation. To get y by itself, we need to minus the 3x over. We're going to have y equals -3x minus 3. And then we're going to go graph it. Starting here at my y-intercept at -3. Interesting, this guy also has a slope of -3. So remember, lines that have the same slope mean these guys are going to be parallel. I'm going to go ahead and graph it down 1, 2, 3, and over 1. Or we could go up 3 and over the -1. You're going to notice that these two lines, because they have the same slope, are parallel, which means they are never going to intersect. Anytime you have parallel lines with the same slope, your answer is that there isn't one. There is no real solution for this. There is nothing that if you tried to put it in here that would also work for here. Now there's lots of things that work here and there's lots of things that work here, but nothing that will work in both because those lines never cross paths.